Hello, thanks for coming. My name is Frederick Servant. I'm the Arnold Software Development Manager, and I'm here to talk about Arnold 5. But first, let's talk about Arnold 4. So I was looking at the first release of Arnold 4, and it was actually 5 years ago. And at that time, we didn't have a plugin for Maya, we didn't have a plugin for Houdini, Cinema 4D, or Katana. And it's been a long journey, and it's proven to be very, very successful and used in many, many productions. So here's a tribute to the great productions where Arnold 4 was used as a main renderer, and awesome work from all our customers. Well, a selection of them, like a Hybrid, a Rising Sun, Cinesight, Trickster with Captain America, NPC commercials, Luma Pictures, Oblique, DreamWorks, and recent work from ILP for Westward, and Rodeo Effects with Valerian. So, Arnold 5. So, the real goal of Arnold 5 was to clean up everything, because it was beginning to be a mess down there. So we needed to really simplify, refactor the API, not from the ground up, but really we knew what we needed to to lay the foundations for the things we wanted to build for the next generation, and along the way we tried to simplify everything we could. Try to simplify the workflows also that were encountered in Arnold 4, and also when you simplify things, you get performance improvements. But we worked also on really improving the speed of the code. So all of this is not very sexy for you users. So we added also a few features that are user-facing, and that's what this talk is about. So the first big feature of Arnold 5 is the addition of the open shading language. And so it's a full integration, so it's not just for textures and patterns, it also includes full closures support. You can see here the list of the closures that we support, and you can see that it includes also the volume closures. So you can build a full-blown Uber surface shader or volume shader with that. You can mix and match C++ and OSL shaders. And if you have lots of OSL shaders that are chained together in a subgraph, they'll be optimized out, so evaluated just once. OSL is available through the use of OSL or OSO files, or we have also an inline OSL shader in which you can just type code. So very early on, we worked with Image Engine to validate the OSL integration while they were transitioning to Arnold in their pipeline, so with Gaffer and all their tools. So we gave them a special cut of Arnold 4, but with OSL included, and because they entirely, or almost entirely, rely on OSL for their shading. And they used it on one production and another. And now they use it on all productions. That's one of the latest ones. So that's Logan, where they rendered this digidouble of Hugh Jackman. And it seems to be working pretty well. So another thing that comes with, that is related to OSL, but not really the same thing, is Lightpath Expressions. So hang in there, that's the most technical part of the talk. So Lightpath Expressions is the new way in Arnold 5 to define AOVs. So AOVs are no longer specific to a shader. They are good for any shader that does lighting calculations, and that you define them once and for all. It's nothing specific to shaders. And I won't go into details on how they are defined, but you see this is this expression language that looks like regular expressions, and this is how you define direct diffuse, indirect diffuse. All this is pretty well documented on our website. Of course, that's not super artist-friendly, so we provide 31 built-in AOVs, and they look like the regular AOV names that you had before, only there's much more. There's a lot more. And now you can decompose your beauty, and it can be as simple as 4 AOVs like at the top, or as complicated as the one at the bottom, and it can be even more complicated. But it should be fairly easy to use, and if you need them to debug some particular AOV, or if you have particular needs for compositing, you can start from one of those built-in AOVs and tweak it. So lights. A lot of the improvements that came in with Arnold 5 revolve around lights. So first improvement is that for the quad light and the spotlight, we added this roundness and this softness parameter that allow you to shape the light from a quad to an ellipsis, and also tweak the softness on the border. So here's an example with a quad light and a spotlight with a gobo. And a lot of the work also has been put in better sampling of lights. So this is actually something that is already in Arnold 4. So those two images have the same amount of the same number of samples. It's roughly the same render time, but just by sampling in a more mathematically exact way the light, you're able to remove a lot of noise when you're shading, when you're in volumes. So we've extended this technique to surfaces, and the result here is quite remarkable because for direct illumination, you can see those images were rendered with just one sample per pixel. You can see that it's noise-free. There's no noise at all in the direct illumination. So don't get me wrong, there's still lots of sources of noise in the render, in shadow and indirect specular and whatnot, but at least the direct illumination is now noise-free. Traditionally, so disk lights were traditionally very, very noisy in Arnold 4 and therefore not used much in production. So we've worked to put them on par with the quad lights and applied the same technique. So this is the result inside a volume and on surfaces. So the result is not noise-free on direct illumination, but I guess you can agree that it's greatly reduced. The math is a bit more complicated in the case of disk lights. Same thing for cylinder lights. Less dramatic improvement, but still an improvement in the sampling. And recently in Arnold 501 with mesh lights, and that's a much more common use case, mesh lights, where you can see the noise is reduced here. It's even more dramatic inside a volume, and that's also a very common case to have mesh lights inside a volume. Here's another example. We think you would like those light sampling improvements. They do reduce the noise a lot. Another similar technique to not really reduce the noise, because those two images have the same number of samples, they have the same render time, but also they have the same amount of noise actually. It's just the noise is distributed in a more visually pleasing way in the image. So this technique is already in Arnold 4 in this case. Was presented by Ilian Georgiev last SIGGRAPH in a talk, and so we apply this technique to all one-dimensional sampling problems such as volume, motion blur, wavelength dispersion, such as this image where you see it improves the quality of the image dramatically. So, as you might have guessed, we've extended this technique to two-dimensional sampling problems. So you have the same dithering now in GI, in area lights, and in depth of field. It's hard to believe that those two half images have the same amount of noise, but they do. one last thing about sampling. So you're now able to clamp the indirect samples and not just all the samples. It's nothing really difficult to do, but it's really useful to remove the fireflies that you get when you have light sources that are close to surfaces. So that's it for sampling. Another big area of improvement in Arnold 5 was shaders. So we had a lot of legacy shaders, and we didn't pay too much attention to shaders for a long time, and it was high time to rewrite them from the ground up and have something that is cutting edge and also production ready. So the first of those shaders is the standard hair, and now it does completely realistic scattering in hair with scattering from hair to hair. It's completely physically based, and we've tried to make it as simple as possible to control it with just four physical parameters: the roughness, index of refraction, the shift, which is the angle of the scales on the hair strands, and the melanin amount to control the color. I'll talk about this a bit later. But also, it was very important to have full artistic controls on the hair shading, and so of course you can have a diffuse component on the hair. As you may know, normally hair are purely specular, but if the hair has some dust on or some paint, or you want to cheat things, or you want to achieve a certain look, you have a diffuse lobe to do this. Of course, they can be emissive for our Japanese customers, and you can change the base color. You can use the melanin or just use any color. And you can tweak the weight of all this. So the melanin. Melanin is the substance in your hair that gives them the color. And it's a simple parameter that goes from 0 to 1 for us. If the melanin amount is 0, the hair is completely white. And if it's 1, it's black. And in between, you have all shades of brown, blonde in between. But there's a second type of melanin that it has a more reddish color, than for redhead. You have another parameter to control the ratio between those two types of melanin. And so, yeah, with just two melanin parameters, you're sure to have a realistic color for the hair. That's extremely interesting if you're doing crowds and you want to vary the hair color. Just by randomizing those parameters, you're sure that you're going to have a realistic color all the time. If you were to do this with just a color, it would interpolate into non-realistic colors. So that's a big advantage, I think. Here's another example. Just a word of warning, it can be quite compute intensive to render especially light hair, but if you're rendering black hair because of a technique called Russian roulette, you won't pay the price. So it's actually a lot faster to render the black hair than light hair. More examples by Andre Holzmeister. What I like about those examples is that Andre didn't know Arnold 5 at all, and just used 3ds Max and ZBrush to do those cool monkey portraits. Right, the second shader that I like to present is a standard surface. So, because our previous standard shader, hard surface shader, was had a lot of shortcomings. A lot of people used the AL surface instead because, yeah, it was not energy conserving, it was not doing the correct Fresnel. So all this is done now, and we've taken all the good features of AL surface, and it's now in standard in the core. And also, we wanted to have the Disney parameterization compatibility. So you have this metalness parameter on this row that you can map very easily to substance texture maps. That was really important given the adoption of substance in the industry for us. So as I said, it's really easy to use. You don't have to You just dial, and it's always realistic and energy conserving now. It still does the good dispersion that we had. Now it's also a lot faster when you have a lot of transparent surfaces, and the refractions are much accelerated because of Russian roulette. It has a secondary specular. We've added in 501 some iridescence, so you can do thin film effects like those bubbles. Also, we supply lots of presets for you to get started really easily. More are coming. One of the objectives also of the standard surface was to make sure that we could achieve realistic skin without needing a special shader for this. So this is an example by Johan Rimmer with a very cool model. Here's another example, more stylized, by Arkady Demchenko on this short film Relict. Check it out. Standard volume. So this one is not, the two previous ones were a complete rewrite. But this one was more an evolution of the volume collector, who worked really well in Arnold 4. We just wanted to have more intuitive controls. So especially regarding density, so you can still control the density with density, but for large-scale scenes, density is not really practical because you end up having a very small density, and it's difficult to dial in just in the UI of the DCCs. Sometimes you don't have enough precision. So you can also have a transparency depth, and that's easier to tweak. Also, the transparency color now is really the color that results and not the color that is absorbed, and that's more intuitive for artists. And if you have a temperature field in your VDB, in your volume VDB, you can do a blackbody emission to do fire or pyro. So here's an example.
Pro, status.
Almost there.
So we worked very early on with Digic Pictures, as they had a lot of smoke effects to do in Final Fantasy, Kingslave, and I mean a lot. They had really a lot. So, and they we gave them the shader, see what they thought, and actually we didn't have a lot of things to tweak. It worked really well for them. They were really happy. It was fast to set up. It's a really fun shader now with the blackbody. Yeah, try it. Cool. Also new in Arnold 501 is the ability to render polymeshes as volume, and with displacement support, so you can do noise displacement like this, or this beer foam. That's pretty cool. Generally for shaders, we've added a lot of shaders in the core, so now there's like 100 shaders directly shipping with the core. And we did this to avoid having DCC-specific shaders, so like shaders specific to Maya or to Houdini. And then when you exported as files from one package to the other, you had to carry around to point to the shaders. So not anymore. So it's a work in progress. But for some of the DCCs, like Houdini, you can export from H2A an AS file. And if you have the same Arnold version, you can just render it in Maya, and you're guaranteed that you're going to have the same result, and you don't need to import any new shaders. So we want this complete compatibility of AS files. So we added also a few new production shaders like Car Jitter, Triplanar. More are coming. Here's a sneak peek of what's coming. There's a new Toon shader that is being developed right now, obviously for our Japanese market. Yeah, it's going to be interesting. So we have a lot of deprecated shaders now because we have replacement for all the old standard, the old volume character, etc. So they're still available in Arnold 5. You can still use them, but they'll be marked as deprecated in the UI, and we encourage you to convert them to the new shaders. Same thing for AL surface, AL hair from Anders Langland. So those we don't really control. It's all Anders's work. But if you've been following the news, he doesn't want to continue developing those shaders anymore, which is good. Because if you want to convert those shaders to the newer versions, including the L surface and L hair, we provide one-click conversions in all DCCs. So just convert. Sometimes we're doing our best to convert them. Sometimes they don't map exactly, so the look might change. But it's a good starting point. Also new in Arnold 5 is complete support for color management. So this is actually a new API, and we provide plugins for this color management system. So it ships with OpenColor.io in the core. And on Maya only, it supports Autodesk SyncColor. And so you can specify the input color space on textures, output on drivers, and also and a rendering color space. And in this rendering color space, all spectral effects, such as dispersion, black body, melanin color, all this take into account the chromaticities of the color space you're rendering in. VR camera, so we have one. It's in. It works. It supports all the good things that a VR camera should be doing. In all the industry protections, it's been optimized compared to the one that was commonly used, the open source version of it that was commonly used in Arnold shops, and supports the pole merging shaders, so you can tweak the poles exactly like you want. Also, lots of performance improvements overall. So take the first line with a grain of salt. It's just, we've observed this. If everything goes well, it depends on the scene, depends on your shaders. But that's what you could expect from upgrading from 4 to 5. Lots of other stuff like faster curves, faster BVH, and more coming. Other features, new in Arnold 5. So, yeah, I'll let you read. We have, I think, for users, the per curve UVs is something that was requested very often. Support for polygon holes is important for Maya users because it means the text now render correctly out of the box. And yeah, many other stuff. That's it for the first round of new features in Arnold 5, and now I'm going to pass to Andrew to talk about Cryptomatte.
All right, thanks, Fred. So my name is Andy Jones, and I'm from SciApp. I'm the head of VFX, and I'm going to talk to you a little bit about what Cryptomatte is and what ID mats are. And introduce a new piece of functionality that we've recently added, and then I'll hand it off to Jonah, and he's going to talk a little bit about how Cryptomatte is fitting into Arnold 5. So I'm guessing most people probably know how mats work, but for the benefit of my mom, who might watch the recording later, basically ID mats let you isolate a specific object in an image and make manipulations to it. So in this example, we're using an ID mat for the monster to change it from sort of a pinkish color to a bluish color. And in a typical scene, you might not know what mats you need in advance. So that's where Cryptomatte comes into play. We are able to provide mats for any object in the scene in an automatic way. So I'm going to show a quick video that kind of describes how the technology works, and then I'll describe it a bit more.
In 2015, we presented Cryptomatte, a fully automatic system for providing ID mats for every material, object, and namespace using a minimal set of images. We use hashes of object names to accomplish this, and as such, names can be used to identify mat selections. Our filtering and encoding techniques allow us to fully support transparency, depth of field, and motion blur. Rendering these mats does not require any special setup in CG, and it's production proven at SciApp. Afterward, we led an effort to turn Cryptomatte into an open standard and released our plugins as an open source project as well. Today, thanks to contributions from the community, multiple compositing packages are supported, and multiple renderers are able to natively produce Cryptomattes, and more implementations are coming all the time.
Okay, so that's basically how it works. There's really two key ideas here. So the first one is that we generate our numerical IDs from the strings that are already in the scene using a hash function. So you get predictable ID values from frame to frame and from shot to shot. We also essentially adapted the idea of ID coverage to use multiple ID coverage pairs. So in this way, we're able to get perfect mats for objects with soft edges that might come from opacity, depth of field, motion blur, etc. So now I'm going to talk a little bit about a new tool that we've released called Cryptomatte. And the idea here, one of the common questions we were getting when we released it is, that's great for people who are rendering things, but I'm compositing. Is there some way that we can use this for compositing mats? So that's where Cryptomatte comes into play. So basically, you can composite additional mats into your set of Cryptomattes or create a new set of Cryptomattes from scratch using things like rotomats, green screen keys, and so on. So it makes it really convenient when you're compositing and you need to quickly access different mats. And we have a Nuke gizmo for this that's available now. It's still in beta, but we would welcome testing and feedback from anybody. So now I'm going to show a quick video of Cryptomatte in action. So in this case, you can see I have a bunch of input mats, and in the middle of the comp, there's a row of green nodes, and each of those is an Cryptomatte node. So as I enable them, you can see the additional mats sort of combining into the Cryptomatte setup. And then once it's finished, you can just click on objects to select them, and you'll notice the names of the objects kind of pop up in the property group. And then when you're done, you can render these out into an image sequence. It's a multi-channel EXR. And you can read them back in and then use those objects to perform different color corrections on your image. So that's Cryptomatte. Now I'm going to hand it off to Jonah, and he'll talk a little bit about Cryptomatte and Arnold.
Thanks, Eddie. Yes, Cryptomatte and Arnold. In Arnold 4, this is kind of about the transition of Cryptomatte from Arnold 4 to Arnold 5. So in Arnold 4, we released Cryptomatte as part of AL shaders from Anders Langlands. That included AL surface, AL hair, AL layer, all of those have Cryptomatte built in. So in that first example up there, the green check mark, that's an AL surface. That will write a Cryptomatte just fine. In the second example, if you're using a shader that doesn't have Cryptomatte built in, like a AI standard, you can use this pass-through shader to make it write Cryptomattes. And the way that a pass-through shader works in general is it will take the result from the standard shader, just pass it through without modifying it, but then do its own thing as well, in this case, writing Cryptomattes. And in the last example there, that's a standard shader without a Cryptomatte pass-through shader, so that, of course, won't write Cryptomattes. And pass-through shaders are not a really great thing for a workflow because you have to remember to install them everywhere. But this was okay because, like Fred mentioned, a lot of people were using AL shaders workflows where they were just using those. And then in the exceptional cases where they had another shader in the scene, they were able to use the pass-through shader so that things would keep working. But again, as Fred mentioned, in Arnold 5, AL surface was discontinued. So we were kind of thinking, like, what are our options here for Cryptomatte? Because if we did this as a pass-through shader, you would have to put them into every single one of your materials in the scene. In my view, that's not okay. It's too error-prone. Somebody's going to forget. Even if you make scripts to set this up for you in your look dev step, somebody's going to make like a one ad hoc shader in lighting and forget to do it, and there will just be lots and lots of re-rendering. So in this dramatization at the bottom, somebody forgot a pass-through shader on one of the monsters, resulted in an incomplete matte and a compositing artifact. A bad one in this case.
So we made a proposal to SolidAngle about how to fix this. And that eventually turned into AOV shaders, which is a new feature in Arnold 5.01. So the way that AOV shaders work, in the case of Cryptomatte, they're not actually Cryptomatte specific, but for Cryptomatte, you put Cryptomatte on your Arnold render globals. So you install one shader in one place, and then every time the renderer renders any sample at all, it'll render the beauty shaders that are there, followed by the AOV shaders. So it's as if you have your Cryptomatte installed in every shader in the scene. And by doing this, we can support all shaders, because we don't have to support any shaders. It's basically just going to work. So it'll work with all shaders, present and future. You no longer have to worry whether Cryptomatte is built into your shaders. The other big benefit is that this gives us one shader in the scene that will run on everything. So that's a really natural place to put global render options for Cryptomatte. Previously, we had two options. We could either do something hacky, like have you define user data on the render globals using the arcane language of that, or we could put a control onto each of the pass-through shaders, and if you want to change your settings in a global way, you'd have to go and change the settings in hundreds or thousands of places. And maybe you even couldn't. Another thing because you might not be able to, because the shader might be in an AS file that you're loading in. And by the way, this works fine on AS files too, so it will work on all the geometry in the scene and not in the scene. So as far as I'm concerned with how AOV shaders stack up against pass-through shaders, I think that AOV shaders are easier to use. They're more powerful, more flexible, and more controllable and modifiable, both for users and developers. If you're a developer working on Cryptomatte, you can easily make a modification, rebuild it, and then just that one thing needs to change. You don't need to worry about having those changes propagated out to all the other shaders in the scene. So in my view, this is really far superior to having it built into the shaders. And we even have some more AOV shaders going at SciOp right now that make use of this functionality, and I think I'm done writing pass-throughs. Yeah. So before I end, just a word about the Cryptomatte project. The goal of the project is to have a robust system of renderers and compositors, both writing and reading Cryptomattes, because the bigger an ecosystem we have, the more useful this is. We've gotten lots and lots of contributions from the community, Anders Langland's being a big one, and we got a Fusion implementation from somebody as well. It was Cedric at Grid, and we're accepting contributions. So if you're working on plugins or anything like that and you want to do an implementation, please get in touch with us. We'll do anything we can to help. And thank you very much.
Thank you, Jonah. So more collaboration. So this was a very successful collaboration with SciOp. More collaboration on more projects. This is a sneak peek. This is not in Arnold 5, but will be. So first, Material X. It's very important for Autodesk to have a Material X support, and so it's important for Arnold. You might have seen Nicholas Harrison's demonstration of the integration of Material X in M2A at the Material X BOF. Another sneak peek, USD Procedural. So this is work by Cynthia Bushma from Autodesk, who's written a USD Procedural. Here's an example, simple example for now, with two instances and a variation of material. Also, this was previously presented, but it's getting improved. So full support for the Bifrost procedural and every geometry that it can contain. So volumes, implicit surfaces, particles, etc. So Arnold 5 is available now. It's been for a while actually, but it's been 2 releases since the version 5.0. It's available on all those plugins, so Maya, Sigma 4D, 3ds Max, that's a new one this year, Houdini, Katana, and Softimage. So it's going to, sadly, we won't be supporting soft image much more, and we're thinking of solutions to give back to the community, but it's, we've been faithful to the soft image users, and so they have Arnold 5 access. One word about the Maya and 3ds Max plugins. So they now ship directly with Maya and 3ds Max, but because the release cycle of Maya and 3ds Max is a lot longer than the Arnold one, I urge you to update from solidangle.com whenever you install a new version of Maya, because they're not up to date. It's well, if you're serious about using Arnold, use update from solidangle.com, and no problem with the licensing. You will keep everything. So yeah, and it's not an additional cost. Also, one question that I get very often, because we were acquired by Autodesk last year, is there a difference between the implementation in Maya, in Cinema 4D, or Houdini? And no, everything is released simultaneously, or we try to. Sometimes when a plugin is behind, but it's just because we have trouble in the development, so there's no evil plan for less features or delay or whatever. It's just us. Sometimes we don't. Well, we try. We try to have it at the same time. Right. Upgrading from Arnold 4. So it might seem daunting in the beginning, but really it's easy. So if you don't have any custom code, you just have conversion scripts for the shaders in all the plugins. So that makes it easy to port your shading networks. If you do have custom code for shaders and procedurals and stuff like this, so procedurals are a bit easier than shaders, because lots of things have changed in the API for shaders. But we provide a porting guide with lots of recipes on how you switch from the code. In Arnold 4 it was like this, and in Arnold 5 it should look like this. And of course we can help. Reach out if you have problems, if you have questions. We will help you. There's a few Arnold 5 resources. So the main hub for you is going to be support.solidangle.com. Well, you'll have extensive documentation about the core, the plugins, all the nodes, the APIs, some tutorials. And I would like to, I'm really proud that it's now available in Chinese and Japanese too. And there's a porting guide there. Some online tutorials to get you up to speed on Arnold 5 and the new way to do things. So from people we like, Arvid Schneider, who has an awesome YouTube channel with lots and lots of tutorials. And Sabaj Lassi, who has courses and video tutorials more centered on Houdini. But there's many others of tutorials out there. And that's it for the presentation. So please download it and try it. You can render with watermarks. It's easy to try. You don't have to pay anything. Access the documentation and support. And I would like to say that we are hiring at SolidAngle, so please reach out if you're interested. Thank you very much. We have time for questions. So, yeah, if you have any question on anything. Yes?
I have a question. I'm just wondering if you guys have any plans to implement something similar to V-Ray's distributed rendering.
Yes, we have. Yes, we have. It's a bit further down the roadmap. It's not going to make it in the next iteration, but yes, it's an item.
Okay, that's good news. Thanks.
Thanks.
I'm a professor from a university, and we just started using Arnold, and we're really enjoying it. I want to know if you plan to support educational license to allow us to render in our render farm, because now it's really tough to render every job in a single computer.
Okay, so yeah, that's a good question. So in practice, we've always had really low prices or made arrangements with any educational institution in the past, and it's been made very clear that we want to fully support free educational licenses. It's taken a bit of time to set it up. Now it's in the latest version of Arnold. The licensing system allows it, so you should be able to do it now. Okay. And you can just all the licenses. I think there's a verification for your educational institution, but it's educational licenses are now free.
Okay. Thank you very much.
Welcome. Any other question? Come on, don't be shy. GPU, good question. So I can't tell too much about it, but it's no secret that we're actively working on a GPU implementation of Arnold. We've talked about prototypes and tries before. This is no longer the case. We're really developing it and trying to reuse as much components as we can from the CPU version. Our goal is to have a full-blown GPU renderer, so not for preview. It's something that you can use in production. And I hope you will have something to test soon.
Talk about OpenSubdiv.
OpenSubdiv. So OpenSubdiv. So we are not using OpenSubdiv, but we are fully OpenSubdiv compatible. So the results that you will get from OpenSubdiv will be completely identical from the result you get from our custom subdivision engine. So we've tried it, we've compared it. We're not, OpenSubdiv is changing also, but from when we tried, it was using more memory than our subdivision engine. And it was optimized, OpenSubdiv was more optimized for GPU. But we might reuse it, but it's evolving also, so it's a work in progress. But we are fully 100% compatible for the limit surface. Yes?
I came in late, so forgive me if you've covered this already, but can you talk a little bit about how Arnold handles textures? I think I've heard that it creates a .tx file.
Yes.
How does that work?
Yeah, so you can use any file format that is supported by Arnold and actually supported by OpenImageIO. So you could render with a JPEG if you wanted. That works, but it's not very efficient. And whenever we have to go to a facility to check some performance problem, that's the #1 thing that we check. Did you convert all your textures to this TX format? So the TX format is it's either an EXR or a TIFF actually behind the scenes, but it's just that the texture is mip-mapped, so you have several levels of of magnification of the texture, so it's pre-filtered. So if your object is far away, it won't load the whole texture, but something that is very pre-filtered and really small, and also it's styled, so it's easy to access just a portion of the image. And that's really important if you're rendering in a render farm, because otherwise just fetching the whole level, mip-map level at full resolution across your network is going to die. So that's why it's important. So new in Arnold 5, we have an API to convert the textures to TX. It's been improved. It's multi-threaded now, and if you don't know, if you don't have a custom pipeline to do your texture conversions, you can just use the automatic conversions from M2A or H2A, and it would, so you can put a JPEG, hit render, it will convert it to TX and render with this. While it does the conversion to MIP maps, it also linearizes it and does the conversion to the right rendering color space. And that's really important to do it at this moment also, because otherwise you get errors that are hard to track. But it's a bit different. It's not very different, but we have to put in some color space specific stuff to support scene color, for example. There's might be a few tweaks, but it's really an Arnold version of it. You'll see this in the metadata, because the problem occurred recently that you didn't know which version of MakeTX produced this. So now it's clear that it was produced with the Arnold version of MakeTX. And you have the version of OpenImageIO also inside. Yes? Yeah. It's full. So it's available in C++ and Python, and it's a queue. So you just put more textures, and in the background, they'll get converted.
Speaking about Meshlight and texture of Meshlight.
Yeah.
Like in Arnold 4, the resolution of the texture or Meshlight depends on the resolution of the meshes.
Yes.
Big stage. There is any chance that you're going to avoid this, so having like full resolution texture on a Meshlight with low poly resolution? That's interesting. Generally, we do hacks, or you can do hacks to have like a high. Because where do you want the high resolution? Is it in the reflection? Is it just for camera rays? Yeah. Sure. Yeah, makes sense. So yeah, for now it's still dependent on the resolution of the Meshlight, but it's important sample. There's all this.
This morning in the session on renders, actually, a lot of people were talking about bidirectional and denoise as well, and Marcus seemed to be skeptical about both of them.
Yes. So for this iteration, we focused on better sampling. I hope it was pretty convincing that we removed a lot of noise. So rather than focusing on denoising, so remove the noise before. But of course, you can't ignore that we need to have a denoiser. We have resources inside of Autodesk and even off-the-shelf denoisers that we need to try. Also, our collaboration with Sony, where they do have a denoiser, might be fruitful here also. So yeah, it's very high on our priorities, but no, sorry, this iteration. We wanted to have better sampling. And yeah, and what was the other part of it? Oh, so bidirectional. So bidirectional is on our roadmap, but further away. But now we're starting to wonder if it's really worth it, because there's been some improvements in unidirectional path tracing also. So the techniques are changing. So actually, we don't know for this one. We have to try. But it was, yeah. So this one we might remove. It's on. So not next iteration, but it was for after. Yeah. Oh, we'll have to try it. Yeah. Because it's not. Yeah, we'd rather have other sampling techniques before, because they will solve more problems for you, we think. And bidirectional is not a silver bullet. It's cool for caustics. But caustics, you don't have this very often in production scenes. What we want to improve really is interior scenes. Yeah, that's the real problem. And we've been trying with different techniques. We added portals. Yeah, and more things are coming, but yeah, that's really the goal. Not caustics, interior scenes. Yeah. More Boolean on render. Interesting. No, it's not something that is on our roadmap right now, but we've had the request a few times. So might be a cool thing, cool feature. Is it really important for you, for your workflow? Oh, yes, yeah, makes sense. Makes sense. So, okay, I'll add one vote. Yes?
Do you guys have any plans to implement a beveled edge shader?
Sorry?
Beveled edge shader into your
Yes, but you might know that the problem here is not really technical. It's more a patent problem, so I can't really talk too much about it. But yes, yeah, we're trying to have it to have rounded edges. It's funny because for the 3ds Max plugin, we worked with Zap Anderson, who's the author of this patent. But now he works at Autodesk, and the patent belongs to NVIDIA. So yeah, so he knows, but we can't do it. Okay. Well, thank you very much.